Santosh is an expert in Earth Engine, to say the least. He'll be telling you what to do for the hackathon to improve your chances of winning, and also to how do you process it. And if suppose you don't have access to Earth Engine, make sure to register right away. Santosh will again show you that, because it takes time, I think, to get access. I've already shared the link yesterday, but because many of you had not joined, maybe I'll share again. So get access to Earth Engine, probably from your college account, because that has high chances of acceptance. From others, it does not. So I'll leave it to Santosh to discuss more. And if you have any questions, just ping me directly. In 1 hour, I'll fix all of those GitHub issues. Thank you so much.
Yeah, just before Santosh takes it up, I would like to thank Aman for that great session on GitHub. And I'll also welcome Mr. Santosh for this session. So the next 1 hour 15 minutes is going to be handled by Santosh. Incidentally, Santosh and Aman both work for Blue Sky Analytics. They are from the industry background. So I now welcome Santosh. Hi, Santosh. A very warm welcome to this hackathon training session. So I would now request Santosh to carry on the session. Thank you.
Hello, is my audio good? Able to hear me?
Yes,
Hey,
Santosh.
okay, thank you. Hello, guys. So I'm Santosh. I am working as a data scientist with Aman in a company called Blue Sky Analytics. Today, I'm going to cover a few important topics that will be useful for the hackathon in Google Earth Engine. Sure. So this is the earthengine.google.com. So I have sent emails to all of you to visit this site. If in case you have not registered for an Earth Engine account, come to this website and click on this Get Started, and you will get this registration form. Fill in the details. And, you can get your free Google Earth Engine account. So I believe everyone has some Google Earth Engine account access. So first, what is Google Earth Engine? So Google Earth Engine is an API platform that has the access to satellite imagery and the geospatial data sets, which we can use it for analysis and create any real world outcomes, which is the core idea for our hackathon, right? So we need to create any real world applications. So it contains the satellite imagery and the pre-built algorithms, and we are going to create in real world applications. So how to access this imagery and do an algorithm, do processing using the algorithm is going to be done in the next 1 hour session. I'm just going to give a brief overview of it. So yeah, let's begin. Under earthengine.google.com, there is a session called platforms, and you can click on this code editor. So Google Earth Engine can be accessed via multiple platforms. One is through this code editor, and the other is through Python, or you can use it through Ruby also. Now we are going to use it via the code editor. That is the most easiest way. And I knew this is not the Python scripting. This is the JavaScript way of writing codes. If you don't know JavaScript, don't worry. You just need to know just 1% of the JavaScript to write code in this. The rest all is the Earth Engine APIs. Okay, so this is the code editor, and the code editor consists of 4 sessions. The first session consists of scripts, docs, and asserts, and the second one is the plane where you can write the code, and the third one is the session that contains the inspector, console, and task. So here, if you have any scripts that is pre-built and it is saved in your code editor, it will come under the owner tab. And if someone has shared a script with you with the write access, it will go inside the write, and the reader is same. If they share with the read access, you will have the read access, and you have the example section. I want everyone to see this example session. If you are a beginner in Earth Engine, this could be like a great help for you. Here, Earth Engine team has already written mini codes, which you can use it. So now this is the scripts, and under docs. So this is the docs, which contains all the Earth Engine function. So here you want to search for any function that can be written in the code. You have to come and search. For example, if you want to create a date under ee.date, you can just come and search which function you can use. And also, if you can type in here. For example, if you want to select a band from a satellite imagery, just select band. And it should and under the e.image, you can see we are having a select function which says that select bands from an image. So this is how we will search for the Earth Engine functions, and that can be used in the code. And the final tab is the asserts tab. So the asserts tab contains all the asserts that are like manually uploaded by us. So for example, if you want a shapefile for your particular region of interest, you can like upload, and I will show you how to upload those asserts. So these are the three tabs in the first pane, and the second pane consists of the code editor itself, and there are a few buttons in the top. So I'm just going to give an overview of these buttons so you can be clear. For example, if I'm typing print, so say for example, this is the whole code, I want to share it with you. I'm going to use the first button, get link, and then copy this link and then share it with the whomever I want to share. Here you want to know there is a triangle button. Don't click on this and use the get link option. So this and the man. Okay, the Earth Engine team has made the necessary updates. So now even if you click on this, you're getting the get links button here, and now you can copy the link from here. So this is the link which you want to share, and if I share it in the chat, you guys can have access to the same code. So this is like a single snapshot. It doesn't work like in Google Docs, where if I'm going to like edit this code editor again, this won't update in the link which I shared with you. Okay, so this is something, and there's a save option. If you click on the save option, it will show you like under which repository you need to save. Since I have like multiple repositories, that's in drop down. If you are a first time user, you just have one repository, and you can just give a file name, and then you can save over there. And that's a run option. So once you write the code, you can just click on this run to execute that particular code. And the reset option will stop your execution. And if you click on this down arrow, that's a clear script which will clear this pane for you. So these are the important buttons you have to be aware of. And if third panel consists of the inspector. So the inspector, if you're having an image over in this map and you want to inspect the values of that image, you can just come to this inspector and click over here, and this will give you the information of that particular image, of that particular pixel. And the console tab is where you're going to print. If you're writing print, right, all the outputs are going to be displayed here. So even if you're like printing an image, if you're printing an image collection, all the outputs will come over here. And when you try to export something, all the export tasks are under this task tab. So I will also teach you how to export in a particular asset to your local drive. So these are the three tabs in this third pane, and the final pane is the maps pane. Here, this contains the base map. You can have this in this view, or you can add the satellite view. So there are two views for this map, and there is a geometry toolbox in the top left. So here you can just add geometries by clicking here. So this is a marker geometry, and there is a line, and there is a polygon, and the rectangle. So these are the geometries which you can add. Okay. So now this is a brief overview of the code editor. Now let's go into the data sets that Earth Engine has. So under this question mark, there is some thing called as user guide. When you go into the user guide, you will have access to the data catalog. So this is the page where that contains all the data sets that are uploaded by the Earth Engine team. So here you can view the data sets. Some lag. Okay, So here, now I'm going to go into the user guide, data catalog, and here is the place where you can view all the data sets. Now let's go into this view all data set tab. So you can see the data sets that are available on the Earth Engine catalog. You can also browse by the tag. For example, if you are working on some atmospheric data set, you can come to this browse by tag section and you can select the particular tag which you want to work on. And you will filter to the data sets that are like tagged in this. So these are the data catalog section. The most used data are the Landsat, this in the Sentinel. So these are available here. Now I'm going to show you how to use the Sentinel-2 data and then create a composite, create an indices, and then export the image from the Earth Engine. Before beginning this, I want to quickly show you how to import assets into Earth Engine. So I have one package called Delhi. So this is the Delhi boundary file. I'm going to upload this into Earth Engine. For this, you need to come to this assets tab and click on this new, and you need to upload a shapefile. As of now, Earth Engine doesn't support any other format than shapefile. For example, geo package or the KML files are not supported. So only you should have it in the shapefile format. Click on this shapefile, and by default, you will have this user's your name, and I'm going to select it from my local disk. And Earth Engine doesn't support the format .qpg, so except that other four formats are selected. You can find these formats that are supported in Earth Engine. So once this is selected, you can name the asset appropriately. Under tasks tab, you will see there is a task running. Now this is first it will ingest the upload the data set to Earth Engine, and then it will ingest the data set into the assets tab. So there are two processes running now. This will take maximum a minute to complete. Once this is complete, we will have our assets under this assets section. While this being done, let's go into the Sentinel collection. As we all know, the Sentinel has multiple products: Sentinel 1, Sentinel 2, and Sentinel 3. I'm going to work with Sentinel 2 data. Under Sentinel 2 data, there are two data sets. One is the TOA and the surface reflectance. Let's go into surface reflectance. And this is the data page that contains all the details about the particular data set. So there will be a section called description where this will contain all the information from where this data set is being scraped and how the processing is being done. And under band section, it will contain all the information about the bands, like what is the band name, description, wavelength, everything. And under image properties, this will contain the metadata of the data. And using this image properties, we can filter from the collection also. And the final is the terms of use. If you want to read about the terms of use of the particular data set which you use, you can always visit this section. So now I'm going to copy this. So before going to this, I just missed one point. So there are just two data types in the Earth Engine. One is the image collection, and the other is feature collection. So image collection is the contains many images, and images are the raster data. Feature collection contains many features, and features are the vector data. So these are the two types of data that can be used in Earth Engine. So now this is an raster image, and this particular data set contains many images, and it is termed as image collection. So I'm going to copy this. I'm going to use it over here. And JavaScript terminology to define any variable is like using var. So I'm just going to use var s2 equal to this particular data set. Now this contains all the data that are captured from 2016 till today for the whole globe. But we need to filter it only for a particular date range, and also filter it for a metadata. Here, let's use the cloud pixel percentage, as everyone knows, each scene will have the percentage of the cloud in it, and we can set the percentage to which we want to filter. So that is the second filter which we are going to use. And the third filter which we are going to use is the boundary filter. So our boundary got uploaded. So here, if you refresh, you should find data called Delhi. It's over here. So I'm going to, if you just hover over it, there will be an arrow over here. This will say import in the script. If you click on this, this will be imported as an asset, and you can name it appropriately. Now our boundary is imported, and we have our raster data. Let's start filtering. So I'm going to name this filter. So now S2 dot. Since we are going to filter, I'm going to go into docs and search for filters. So these are the filters we have currently, and the first filter which I'm going to use is the date filter. For that, I'm going to use filter and e.filter.date. Once you put this parenthesis, and if you press Control and space, it will automatically fill the parameters that have to be filled in here. So wait, I'll just do this again. So we are just going to use e-filter.date, and when you apply this parenthesis and press Control space, the parameters will be automatically filled, and we can turn this into a dictionary start, and the start should be a string. So I'm going to filter it for 2020 January 1st to 2020 February 1st. Another thing, the end date is not considered. So if you give the February 1st as the end date, the actual end date will be the 2020 31st of January. So once we do this, we can close this. So now this particular collection is filtered for this particular date. Now we can start chaining the other filters also. So I'm going to do me.filter, and I'm going to filter to a particular metadata property. For that, we need to find what we are going to do is filter all the images that is having less than or equal to 20% of the cloud cover. So less than or equal to, we can search over here, and there is a filter called the efilter.lte. If you click on this, you can see the filters of the metadata less than or equal to. So let's use this filter. And the process is the same. Control space. You will autofill these parameters. And in name, you can come into this data catalog under image properties. You have this cloud pixel percentage. Copy this, and then you can paste it here. And the value, I'm going to give it as 20. This is the second filter which we have written. And the third filter I'm going to do is boundary filter. For the boundary one, you can search again here, and you can see there's a filter called efilter.bounds. So I'm going to use this. This bounds accepts the geometry. As in here you can see it is also accepting in feature collection, but it is always advised to given geometry as input. So how to extract the geometry from this feature collection? So it's daily.geometry will extract the geometry of this particular feature collection. Okay, let's print this filter collection to see how many images we have filtered. Print this. Under this console, you can see we have just filtered to 15 elements. So this 15 elements is corresponding to the region Delhi for the time range of January 2020. Okay, now if we try to add this will fail. I'm just going to show you why it is failing. So here you can see a particular image is being added, but that is not the image which we actually require. So we need to we're going to do is first let's create a mosaic map of this. And if you search in here for mosaic, you will get the function that can be used to create a mosaic out of it. And then I'm going to add this to the map. And in the data page, under bands, there will be some code that is written by the Earth Engine team, which you can use it as an helper. I'm going to copy this visualization parameters which they have used, and use the same visualization parameter. I'm going to name it as Sentinel. Okay. So again, this won't be like looking as we expected, because if you inspect the values, you can see it is all 2000, 3000, 4000. But as in remote sensing background students, you might have known the reflectance will be ranging from 0 to 1. So here under bands, if you check, there is a parameter called a scale. So whenever you look into the data page, you should see for the scale. So what Earth Engine is doing is it is actually multiplying the floating point values using this particular number to convert it as an int, so they can store these images efficiently. So what we can do is we can say mosaic. Now we have to descale it. So now you can see we got this RGB composite image. So this is the true color image which we usually create using the bands 432 20 Sentinel-2 collection. Okay, so this is the one form of creating mosaics. And the next thing I'm going to show you is how to create in composites. So apart from Earth Engine, creating composites is difficult. So this was not widely used, but nowadays, since with the powerful cloud technologies, we can create composites. The composites are like if you're having an image of 15 images, you're going to compute an statistical value out of that particular image stacks. So what I'm going to do is create a median composite. And descale it. And then add it to the map. So first let's load the mosaic, and then we will load the median image. As in here you can see, since this is a median statistical value of the particular stack, we are having less clouds over it. So this is one way of like getting in cloudless image. Also, we don't want the image as in rectangle bounds. We can clip it to the particular region. So I'm going to write dot clip to Delhi. Okay, so as of now we have so how to filter for the data set, and then how to import it and export the data, how to write filters to particular data set, and then upload the data sets from our local disk and create composites using the data sets. Okay, now I'm just going to demo you how to create indices and then export the result to your drive for further analysis. So let's create an NDVI. So I'm going to take this median image. So as we all know, NDVI is the normalization of band 4 and band 3. So here under image, you can see there is a function called normalized difference. So I'm going to use this normalized difference and then input band 4. When you use this normalized difference function, it will automatically name the particular image as .nt. So you can use the rename function to rename it as NDVI. Now let's add this NDVI map to our canvas. Add layer. I'm going to add this NDVI and clip it to Delhi. And here there is no predefined visualization, so we have to write our own. I'm going to use the minimum value as 0 and the maximum value as 1. And I'm going to introduce you to an site called Color Prover. So here, this is the site I use for like getting the color palettes. And excuse me. Yep. So here we will get the color palettes. I'm going to copy this green color palette and the palettes. Is this? And name it as DBA. Now if you run it, or we can change the parameter as 5 over here. So this is the power of Earth Engine. As you can see, we have uploaded our local disk file and then filtered this into collection for the particular date range and then created a median composite and added it to the map for the visualization. So all this, if you are like familiar with Earth Engine, it can be like done under 2 minutes. So if you want to do it apart from Earth Engine, it takes a lot of heavy lifting, like you have to download the images, filter for the particular metadata, and then say load it into Python or something, and then create your composites. Okay, so now I'm going to show you how to export images. So under this, you can see this image looks great here, but how can I add it to my report, or how can I show it as a solution to other clients? For that, you need to export it to your local disk. We are going to use the export image to drive. So let's do it here. Export image to drive. And the drill is same. You have to press Control space. It will autofill the parameters. And which image you want to export? It is the NDVI image. And the description, I'm going to give it as NDVI. I'm going to name it as demo folder, but you can name it accordingly as per your project. And the file name prefix is the name for the file you're going to export. I'm going to give it as Delhi NDVI 2020 Jan. And we can omit this dimension parameters. Under region, you can select Delhi.geometry. And this scale is the resolution at which you want to export the images. So I'm going to give 30 meters, but yeah, the data is 10 meters. But to have a fast export, I'm just going to give it as 30 meters for time being. And under max pixels, you can give 1e12, that is 10 raised to 12. So this is set to 10 raised to 7 by default. Earth Engine has set this to avoid an accidental export. As you know, this is a heavy computation process. Someone who doesn't know what he is doing, like if they kickstart this process, it will use a lot of compute. So to stop this, they have set this to 1e7. We can increase it as we know what we are doing, and we can omit other parameters. Now, once this function is written, you can click on the run, and now under tasks, you will have a task ready for you. Here you have to click run, and you can check the details which you have given. And if you click run, this will start to export. This will take a couple of minutes. Until then, I will show you how to write map functions. So if you have used any coding before, for example, someone has said they have used for, and many of you would have been familiar with Python. There you would have used for loops. In Earth Engine, it is highly advisable to not use for loops. Why? Because Earth Engine is designed in such a way to do parallel computing. If you are using a function such as for loop, it will be an iteratable computation. So iteratable computation will take time. So to take the advantage of the parallel computing, you need to write it in a different format. So there is a function called .map. So under feature collection, if you see, there's a function called maps. It maps an algorithm over a collection. So we need to input an algorithm over here. For that, first we need to write the algorithm. Okay. So now I'm going to write an algorithm to compute NDBI. And you can just watch my screen. This is the syntax for writing an algorithm. So first you need to define the name of the algorithm and then define it as a function and what is input that is going to go inside the function. So I'm going to give an input of image and then I'm going to compute the NDVI. So image dot and normalized difference of this. So I'm just going to copy it from here. And each function should return something. So I'm going to return the NDBI image. Okay. So now what I'm going to do is I'm going to take this filtered collection. So this is an image collection that consists of 15 images as we have seen here. And for this each 15 image, I'm going to compute NDBI. So I'm going to create a variable called NDBI collection and filtered dot map and pass in the algorithm as compute NDBI. Now let's print this NDBI collection. This contains 15 elements and each element is an image with single band and that band is NDBI. So this is how we can create NDBI for each element in a particular collection. We can also add this to the map. And use the same visualization parameter. So this is the image that has got generated using this map function. I'm going to take a pause for like 2 minutes. If there are any questions, I can answer them. And then we will continue how to do charting and time series. And then I'll show you a demo of how to create an app, and then we will conclude the section. If there are any doubts, you can ask. If there are any doubts for team, I can just go into the team and explain them whenever they need it.
Can you share some resource with them? How do you follow along?
Sure. So okay, I will share 2 scripts. So the first script contains all the code which I've typed now, and also it contains how to use the map function, how to export and import. And the second script contains the resource how to create Earth Engine apps. And also
maybe you can walk through the code for app.
Okay, I can share. But is it like my audio good? And if you guys are able to follow, I can do it.
Yeah, now it is better. At least it's not hanging.
Okay, sure. So this is the code for creating an apps. So I purposefully missed this button apps when I was introducing the Earth Engine code editor. So Earth Engine has an functionality where once you have built some real world solution, you can build that as a geo app and publish it on the web. And the user doesn't need any Earth Engine account to view that particular app. So to create those kinds of applications, what we need to do is there's a particular syntax which we need to follow. So what I'm going to do is I'm just going to import this Modis collection and then load the 2021 March data in the left side and the 2022 March data in the right side, and then do a side-by-side comparison. So here, as you can see, I'm just creating the date from the from MYD function, and then create the end date using the advanced function. So this is the start date and end date, and using the EEFilter.date and creating a mean composite. So this is for the image one that is going to go on the left side, and the image two is the same but for 2022. This will go on the right side. So now I'm going to comment this full code up to this. And I want to show you what this UI.root.clear is going to do. So if I click run, you can see the base map has vanished. Since we had a single base map, we need to clear that map outside, and then we need to input 2 maps. So what we are going to do is create 2 maps. To create that, we can use UI.map. So I'm going to create map 1 and then say map 2. And there is an option called linker. I'm going to use it to link these 2 maps. And let's create the split panel app. So UI.split panel, the first panel is the map 1 and the second panel is the map 2. And how this is going to be linked, it is by a horizontal, and wipe is going to be true. Can I ask Santosh how I will know all these parameters? Just go into the docs, search for split panel, and under split panel you will get all the parameters. So now from here only I just copied and then paste over here. Okay, after creating the split panel widget, what you can do is add the image 1 to the map 1 and add the image 2 to the map 2. I hope now this is clear. This is just 4 steps required to create a split panel app. And when you click run, you can see now the map panel contains 2 maps with an sliding widget. So this particular image is the March of 2021 in DVA. You can zoom into any particular location. And when you slide this to the left, this will load the March of 2022 in DVA. So now you can see the difference as a side-by-side comparison. And once this is created, what you can do is click on apps. I have this apps built, but you'll have a plain app section. here click on new apps, and then say you can IEEE demo. I'm just going to name it, and then click next. And I'm going to use only the current content in the editor. If you click on the repository script path, then if you make any changes to the code which you have written, it will also reflect in the app. But if we choose current content as the editor, then if you make any changes to the code in the future, this won't reflect to the app. And then click next. And if you have any logo, you can upload it over here, and you can click publish. So now my app is published. Once you click here, it will take a couple of minutes to publish this app, but I'm sending you guys this link. So even without any Earth Engine account, any user can access this data. This app will be published in 2 minutes also. While it's being published, if there are any questions regarding publishing apps, I'm happy to answer.
Yeah, now it is published.
Okay, so now this is the app we just built, which is the 4 steps. So I'm just going to run over the steps again. Create your first image, create your second image, clear the base map, create 2 base maps, and then link it. Write an code for split panel app, and then add the map to the respective maps, add the images to the respective maps. And here you can see we have the split panel ready, and we can check the side-by-side comparison. Cool. Yeah, I think that's it. If there are no more questions, we can proceed to the next section.
So if there are any questions, you guys can ask. Any questions, say your analysis. If you want to do it Earth Engine, how do you do it? You can ask Santosh. Or you can type in chat if you don't want to speak.
Yeah, I think when we go to the teams respectively, we will have a discussion with them. So it should be fine.
Cool. Okay, so I think that concludes this session as well. Now we'll head on to lunch break and see you back in what is the schedule? 2.
Yeah,
2:30?
just I have one more thing to add before going to
Yes,
the
sir.
lunch break. There are a lot of participants who have not yet given the email ID of the team lead. Can you guys please enter the team lead's email ID? For example, we have Nishikanta, Dheeraj, Pranjal, Titidatta, and Sohan. Sanket, Anisha, Lalu, and we have Patil, Hindurao, Abhishek, Dakshayani, Sanjay NC, and Hima Vamsi. So request you to kindly enter the team lead's email ID at the earliest so that we can announce the topics by the end of the session. That is one. And meanwhile, before we enter the lunch break, I would like to thank Santosh for the insightful session on Google Earth Engine. So thank you, Santosh. You have started from the scratch, and I hope the participants have gained knowledge about Google Earth Engine and its application as well. And also now I'd like to request 2 or 3 participants to share their feedback from the morning. It can be anyone. Please come forward. So please feel free about the sessions, or if you need anything else, you can also ask that. One or two guys, if you could come online, unmute yourself. Yes.
Raghavendra is here. Raghavendra, maybe you would.
Yeah, please go ahead.
Hello. Am I
Yes,
audible?
Raghavendra.
Yeah, very good afternoon all. From morning, it was a wonderful and insightful session.
Just let me interrupt 1 second, Raghavendra. Please introduce yourself, your name, which institute you are coming from, and your degree. Thanks.
Okay. Very good afternoon once again. I'm Raghavendra SP. I'm pursuing MTech Geoinformatics at Karnataka State Remote Sensing Application Center at Bangalore. So the organizers have been very helpful and kind enough in taking up all the activities and making sure that every participant gets their share of information in a very effective and a convenient way. I special mentions to Aman and Santosh for taking this work in a very workable fashion so that each and every participant gets the study and the information as such. Thank you.
Thank you, Raghavendra.
Yeah, we need one more participant from UG, right, Aman? We have a lot of UG participants. So
Yeah,
please
we
come
have a lot of
forward. Okay, I'll do the regular routine by which I'll pick up the student so that they'll speak. We have with us Asha. Asha, are you there? Asha M.
Yes, sir. Yes, sir.
Yes, Asha, go ahead.
Good afternoon, all. My name is Asha. I have completed my MTech in Geoinformatics from KSR, Karnataka State Remote Sensing and Application Center. This session is very helpful, and special thanks to Santosh sir for guiding us with Google Earth Engine. It is very helpful session. Thank you.
Good afternoon, everyone. I'm Ananya from the National Institute of Engineering, MySir. The sessions were very helpful. We've studied QGIS before, but we've forgotten most of it, and this was very helpful to refresh our memory, especially a session in the morning. And learning about Google Earth Engine was also really informative for us because we haven't done anything with it before. So I hope we can use all these tools in an effective manner for the hackathon. Thank you, everyone.
Yeah, that's great to hear, Ananya. And you have to use it effectively because now we are in a pool of competition with UG, PG, PhD, MTech, everyone is involved. So you can understand the competition of this hackathon. I'm very much sure that even if you are undergraduate level, no need to worry. You can definitely come up with brilliant ideas, right? So the same thing holds good for the MTech and PhD also. I encourage all of you to pick up a topic of your interest and work on it for the next 1 or 2 days. Over to you, Aman. Thank you.
Thank you, sir. Okay, cool, guys. Thank you so much, sir. Thank you for taking up the charge to help us organize this event. So for the first half, we have completed QGIS, Earth Engine, and GitHub to set up. Those who have not filled email, please do. We'll start the next session at 2:30, as mentioned. In that session, from there on, you'll be getting your topics, and also we'll have a small discussion which region of interest you have to choose. And after that, you can start with your work. So the second session is very important. You can start at 2:30 with GeoPython. I'll show the basics of how do you load shapefiles and geo packages using Python and Kepler GL, some with stack APIs. So those kind of things we'll just brief over, and we can take over. So thank you all. See you everyone. See you all at 2:30 sharp. Okay. Thank you so much.